The universe, as we know it, began around 13.8 billion years ago with an event we call the Big Bang, a moment of unimaginable energy where space and time themselves exploded into existence from a point of infinite density. Or, at least, that's what the standard model of cosmology tells us. But what if there was more to the story? What if the Big Bang wasn't truly the beginning? What if something existed before? The James Webb Space Telescope, humanity's most advanced eye in the sky, has been peering deeper into the cosmos than ever before. Designed to detect the faintest glimmers of infrared light emitted billions of years ago, Webb is uncovering ancient secrets buried in the fabric of space-time. And recently, it may have glimpsed something that challenges everything we thought we knew. A mysterious signal, a whisper from the dark edges of time, hinting at something chilling that may have happened before the Big Bang. Let's rewind. Before Webb, our primary window into the ancient universe was the Hubble Space Telescope. Hubble allowed us to peer back around 13.4 billion years, capturing stunning images of early galaxies and nebulae. But Hubble, as powerful as it was, had limits. It couldn't see through the cosmic dust that veils the deepest parts of space. Webb, however, was built for this exact mission. Its infrared sensors can peer through that dust, accessing a realm of the universe that was previously invisible. Webb has detected galaxies that appear to be too old, too massive, and too structured for their place in time. In other words, they shouldn't exist. These galaxies, seen just 300 million years after the supposed Big Bang, are mature, complex, and filled with stars that look like they've been around for billions of years. This is puzzling. According to the standard model, galaxies need time to form. Gravity slowly pulls matter together, stars ignite, galaxies spin into shape. But these newly detected galaxies are skipping steps, emerging far too early in cosmic history. How could this be? Some scientists suggest that our understanding of galaxy formation needs updating. Others think that maybe dark matter played a more significant role than previously believed. But a more unsettling theory is gaining traction in some circles. A theory that suggests time itself may not have begun with the Big Bang, that perhaps the Big Bang was just a transitional phase, not the beginning, but a continuation. To understand this, we need to explore the concept of cosmic inflation. Right after the Big Bang, the universe expanded at a rate faster than the speed of light. This inflation theory explains why the universe appears so flat and uniform, but there's a catch. Inflation theory can't explain what started the inflation, or what came before it. Some theoretical physicists have proposed a bold idea, that the universe we inhabit is just one phase in a never-ending cycle of expansion and contraction. In this cyclical model, the universe goes through a series of bangs and crunches, expanding, slowing down, collapsing, and rebirthing again. If this is true, then the Big Bang wasn't the beginning of everything, just the latest reboot in an eternal cosmic cycle. And if that's the case, then traces of the previous universe might still exist. Fossils in the radiation, imprints in gravity, shadows that linger in the farthest corners of the cosmos. This is where the James Webb Telescope comes in. Among the streams of data pouring back to Earth, scientists detected something unexpected, an anomalous signal embedded in the cosmic microwave background. This signal doesn't match the known patterns left by the Big Bang. It's older, stranger, and it seems to hint at a pre-Big Bang structure. Some researchers describe it as a kind of cold spot, a region in the sky that defies statistical explanation. Others have speculated that it could be the echo of a black hole from a previous universe, bleeding into our own through some kind of quantum memory embedded in space-time. These are not mainstream ideas, at least not yet, but the consistency and repeatability of Webb's findings are pushing the boundaries of accepted theory. If the telescope is truly detecting structures or energies that predate the Big Bang, it means we need to rethink the very foundation of physics. It suggests that time might be far more fluid and complex than we ever imagined. And then there's the chilling part. If our universe is part of a cycle, if there was something before, and there will be something after, then what happened to the universe before ours? Did it collapse into a singularity, leaving behind only dark echoes? Was it destroyed in a final cosmic war of matter and antimatter, or did it fade slowly, drifting into entropy until there was nothing left to sustain it? Webb might not just be showing us the birth of our universe, it might be showing us the death of another. This discovery raises another profound question. Could intelligence have existed before the Big Bang? If there was a universe before ours, could it have evolved life, perhaps even civilizations advanced enough to leave a message, a signal, something for the next universe to find? And is that what Webb is detecting? Not just a physical imprint of the last cosmos, but a deliberate mark left by beings who knew their time was ending. Some data from Webb include subtle variations in light that some speculate could be unnatural, patterns that repeat too precisely, frequencies that align too consistently across vast distances. To some, it's just noise, data artifacts. But to others, it's eerily similar to the kind of encoding we use in digital communication. Could it be a message, a cosmic transmission sent across cycles of creation, from one universe to the next? Of course, these ideas are still highly speculative, but even if they are only partially true, they change everything. The idea that the universe has a memory, that it could carry information from one epoch to another, transforms the nature of reality. Suddenly, we're not just looking into space, we're looking into time itself. Deep time. Time that stretches not just billions, but trillions of years across cycles of existence we are only beginning to grasp. But what kind of information could survive such a cataclysmic reset? The end of a universe is not a gentle fading. It's an implosion of unimaginable force, a collapse of all matter, energy, and even the laws of physics as we know them. For anything to endure that kind of event, it would need to be more than just matter. It would need to be fundamental, embedded into the very structure of space-time itself. Some theorists point to the concept of conformal cyclic cosmology, an idea proposed by physicist Roger Penrose. According to this theory, the universe goes through infinite cycles, called aeons. At the end of each aeon, as the universe expands and all matter decays, what's left behind is pure radiation. Time and scale become meaningless in such a smooth, empty cosmos. In this bizarre state, the infinitely large starts to look like the infinitely small, and from this strange equivalence, a new Big Bang emerges. What's fascinating is that Penrose suggests that information can pass from one aeon to the next through radiation, particularly gravitational waves or other imprints on the cosmic microwave background. He claims to have already found evidence of this, mysterious concentric circles in the radiation map of the sky, which he interprets as echoes of black hole collisions from a previous aeon. Webb's ultra-sensitive instruments, capable of detecting the faintest patterns in the oldest light, might be picking up more of these eerie fingerprints. If this is true, then the James Webb Telescope isn't just looking into the past. It's decoding messages from a forgotten time. Every pixel of ancient light could be telling a story, not just of stars and galaxies, but of events that occurred before space and time, as we know them, were even born. Of course, most mainstream scientists remain cautious. Extraordinary claims require extraordinary evidence, and while Webb's findings are intriguing, they still need rigorous confirmation. Yet, the implications are staggering. If Webb has truly uncovered evidence of pre-Big Bang phenomena, it means the story of our cosmos is far older and deeper than we imagined. And here's where things get even more unsettling. If the universe is eternal, if it's been cycling through aeons forever, then so have the laws that govern it. And if intelligence can arise once, like it did on Earth, it can arise again. Or perhaps it already did. Not just once, but countless times, across countless cycles. What if the universe isn't just a machine producing stars and galaxies, but also civilizations? What if intelligent life is not the exception, but the rule? What if we are just the latest chapter in a saga that stretches back into previous universes? This leads to one of the most chilling ideas of all, cosmic recursion. Imagine a universe where intelligent life advances to the point where it understands the very mechanics of reality, where beings figure out how to encode their knowledge, even their consciousness, into the fabric of the cosmos itself. As their universe dies, they send out a final signal, a kind of cosmic seed, waiting to be picked up by the next universe's first intelligent species, a transmission across aeons. And now, for the first time in human history, we may have built a tool sensitive enough to detect it. Of course, the implications are mind-bending. What if the very laws of physics have been influenced by prior intelligence? What if we live in a universe that's been designed, not in a supernatural sense, but engineered through physics itself? If civilizations can shape the properties of the next universe, then we might be living inside a cosmic project. one built by beings who once looked into their own skies, searching for meaning just as we do now. This is not science fiction. These are real questions being explored at the fringes of physics and cosmology. The James Webb Space Telescope has opened a new window, and what it reveals is far stranger than we ever anticipated. Not just galaxies that shouldn't exist, or structures that appear too early, but perhaps signs that something came before, something massive, something intelligent, something chilling. The idea that the Big Bang wasn't the beginning opens doors to a kind of existential vertigo. If there was a before, what caused it? What was it like? Could it happen again? Are we on the verge of another transformation, another bang, another cycle? And what about time? If time began at the Big Bang, as most theories suggest, then how can anything exist before it? But quantum physics has long hinted that time might be an emergent property, not a fundamental one. In certain quantum gravity models, time doesn't exist at all at the deepest level. It emerges only when particles interact in specific ways. That would mean the concept of before the Big Bang is not only valid but necessary to complete our understanding. So, what does this mean for us, for humanity? Perhaps we are not alone, not just in the vastness of space, but across the endless depths of time. Perhaps the story of intelligent life is far older than Earth. And maybe, just maybe, the cosmos is not a cold, indifferent place, but a living narrative, written, forgotten, and rewritten again and again. The James Webb Space Telescope is not just revealing new stars, it's peeling back the layers of reality. And buried in those layers, we are beginning to see the first glimmers of something ancient, something that has waited billions of years to be seen again. As Webb continues its mission, we may find more anomalies, more impossible galaxies, more signals that don't quite fit. Each discovery will bring us closer to the truth, whether it's evidence of previous universes, encoded messages from extinct civilizations, or the fingerprints of a deeper order beneath the surface of reality. One thing is certain: the universe is far more mysterious and far more alive than we ever dared to imagine. And perhaps the most haunting question of all is not what came before the Big Bang, but what's coming after.